Good afternoon to everybody in attendance. Like Randolph said, my name is Peyton Campbell. I'm the applications engineer at AFL that's responsible for our transmission compression products. Today, we're going to be talking about the different compression connectors that we offer, a little bit of the history behind those accessories, and then how we kind of design those accessories as well. So to start, we'll kind of talk a little bit about all the different products that AFL offers. As you can see, there's a wide variety here, both inside the fence in substation applications and outside the fence in your transmission and distribution cases. Today, we're primarily going to focus on transmission compression products. So those will involve things such as our compression dead ends and some of our other compression products as well that are listed on here. Just a brief history to go over all the different products that AFL has offered. AFL has been in the business of transmission compression for over 100 years now. If you notice in our images here, you can see some old grainy pictures that kind of show some of the same type of technologies that are even used today in the industry. But back then, we originally made accessories out of cast aluminum tube and a bored steel rod. And then for larger diameter products, we ended up using cast aluminum tube with a large socket. Each of those compression fittings were then filled with molten zinc that was prepared in the field. Nowadays, we end up using filler compounds to help keep moisture out of your accessories and conductors whenever we make those compressions. If we notice here in the right image, you can notice that there is still a steel pulling sleeve accompanied by a pocketbook grip style come along. Then in the bottom here, you can actually see the same type of press head that we use today, along with a manual hand pump. Nowadays, we either use gas-powered or battery-powered pumps to install these products. Just to kind of reiterate on the history, you can see the date here in the bottom left corner where the origination of AFL's involvement with compression connectors dates back to the 1920s. So this is basically an installation and structure procedure for a two-stage compression joint for ACSR. ACSR has been around since the beginning, and this is how we developed our technologies back then. Then in the late 1950s, we divested of our cast aluminum products and went to a seamless drawn tubing for our compression accessories. With this, we were able to make a lot more of outer diameter and inner diameter combinations to ensure that we get the proper amount of compression over a wide variety of conductor types. This is also when we introduced our aluminum hex type dies, or the AH type dies, and they were further developed to help get a more accurate compression, more detailed compression over different types of conductors. So just to kind of iterate on the different types of conductors we make accessories for, as you can see, there's 16 different types of conductors here, varying from ACSR, ACSS, all aluminum conductor, all aluminum alloy conductor, ACAR, self-dampening and vibration resistant conductor. There's also oval conductor listed on this sheet, but that is the only type of conductor we do not make compression accessories for. Every other conductor that's on this slide here, AFL makes compression accessories for installations in the field. A couple others that we make accessories for are composite core conductors. We've been involved with 3M, Southwire, CTC, and TS since 99, 2010, and 2018, respectively. And AFL is actually the sole USA provider for 3M, TS, and C7 accessories. Now we'll kind of cover all the different connector types that AFL offers. Those will be classified into basically two different types of products. We have full tension and partial tension. Your full tension fittings are going to be that of your dead end and your joint, as shown in this diagram. Full tension fittings contain a two-piece component, that being they have a steel component where with ACSR, we're going to use that as an example. Your steel eye has a compression barrel, and we'll end up talking about that here in just a minute, a little bit more in depth. But there's a barrel on the dead end eye that presses over the steel core of an ACSR conductor, and there's a steel sleeve that's contained within a compression joint. And then along with the steel component, there's the aluminum component, which you can see with the body on the dead ends and joints. The full tension fittings with the dead ends and joints are rated for 95% of the conductor RBS as per ANSI requirements. And the other type of fittings that we offer are partial tension fittings. Those include jumper connectors, terminals, T-taps, and repair sleeves. Our jumper connectors and terminals are rated for 40% of the conductor RBS for holding strength. And the repair sleeves can actually restore up to 95% of the conductor RBS if a third or less of the aluminum strands are damaged. T-taps also are a two-piece system where we use an extruded section that's cut away that can slide over a full section of conductor. And those are used to be able to tap off of your lines and go into either substation, either on a jumper span, or you can use them on the line to tap off into a substation in that application as well. To classify a couple of different families that AFL makes compression fittings for, we have two-stage operations and single-stage operations. Now, I know we talked about there's two different types of products being full tension and partial tension, but AFL makes two-stage products and single-stage products as well that also incorporate all those different fitting types that we saw in the previous slide. So two-stage operation, pretty straightforward. It's a two-step process where we use a steel component and an aluminum component, as we just mentioned, where we press a steel over a steel core to join the steel strands. And then we have the aluminum component where we use the dies to then compress over the remainder of the conductor. We also make single-stage accessories. Single-stage accessories means we only use one set of dies to be able to join the aluminum and the steel strands all in one step. And we'll get into a little bit of the details of the different products within those different fitting types that we offer. So what are we compressing exactly? In this video, you can kind of see an example of us pressing over the body of a two-stage dead end here. As you can see, we use, in this slide, we have a 100-ton press using the type dies. And we're pressing over the remainder of a body here that presses over the outer strands of your conductor. You'll notice there's overlapping die bites where we start at a certain start mark along the body, and we'll make overlapping die bites all the way out to the end of the accessory here. All right. So to cover our two-stage standard temperature accessories. So this has been the technology that we've been using for over 100 years now. So two-stage standard temperature accessories are going to be used on your ACSR conductor. These require the steel hex and the aluminum hex dies, which are the SH and AH dies. With this product family, the eye or clevis can be orientated at any desired location. And what I mean by that is if we look here at our eye, it's loose. If you'll notice in our diagram here on the cross section, you'll see where there's compressions made on the outside with our aluminum hex dies over our corrugations of our steel eye. But before compressing the aluminum body over the corrugations of the eye and then over your conductor, you can freely rotate this eye in any direction you need to, depending on which direction you press it over your steel core here. So it can be freely rotated. It can be in a vertical orientation as shown here. It can be in a horizontal plane along the center line shown in the cross-section view here. It does require the field injection of compound, which if you notice in our cross-section here, there's a little plug hole here where we inject filler compound. And then for operations, it's good for 100 degrees Celsius of continuous temperature, and then good for up to 120 degrees Celsius for emergency or temporary loads. For installation of this type of product, you'll notice we have our two dies like we mentioned earlier. You have the SH dies that are pressing over the steel eye barrel like we were talking about just a second ago. That presses over the steel core of the conductor, as you can see here. And then we use the aluminum hex die to make a few compressions to lock the eye in with the body over these corrugations. What that does is it keeps everything together whenever tension's applied after installation. It keeps the aluminum and the steel together, And then to increase our holding strength and our electrical continuity, you will skip over the section where we press over our steel and then press starting at where our conductor is and press all the way out to the end. Just to kind of show a comparison between what a dead end and a splice is, or how they are made, you'll notice we have a center line here that's mirrored about. So practically, if we were to take the dead end barrel off of the eye and mirror it on a plane, this is what the mid-span splice would look like. So for installation here, you would have your two legs of conductor. You would press over one half of your steel sleeve here on one leg, press the other half over the other leg, and then make the similar compressions once you center up your splice body here and inject it with compound in the process. We also make high temperature accessories as well with two-stage fittings. So our high temp accessories are designed for ACSS and ACSS TW. They are to be used with GA, MS, AlumaWeld, and EHS cores. These also require the two die system, so the same type of SH and AH dies that would be used. These require the injection of high temperature filler compound, and they are good for up to 250 degrees Celsius of operating temperature. Our high temperature accessories can also be used, excuse me, on ACSR with the same code name or stranding, or KC mill size and stranding. So if we were to use Drake ACSS, for example, we would have a high temperature two-stage dead end and splice for Drake ACSS, but if you were to use the high temperature accessory on Drake ACSR, that would be perfectly allowable. The difference between our high temp and our standard temp accessories, we dead soft anneal the barrel of the high temp version to match the annealing of the strands on your high temperature conductors like ACSS. That way it helps protect the conductor a little bit more. And whenever we get up to those elevated temperatures, up to 250 degrees C, if you were to use a standard temperature accessory, it wouldn't anneal the accessory over time. The limitation with this, our standard high temperature accessories cannot be used on other conductors with high temperature low sag conductors, such as your ACSS with MA5 grade cores or any of the new composite core conductors. We have special accessories that we use for those types of conductors, whether it be a UHS style fitting or for the composite core conductors, we have special accessories for those as well. To kind of show you how the accessories work, if we look at this graph here, you'll actually notice our location. If you look at 0, this is where the mouth of our splice here in this image here is. This was done on Picos ACSS trap wire and 8040.162 HT splice, the splice body that's intended for Picos ACSS trap wire. You'll notice our ambient temperatures are around 24 to 26 degrees or down to 21 degrees Celsius. And then we end up having a target temperature on the conductor. We go from 300 C to 100 C. And if you'll notice, this is where your conductor is. And as we approach the mouth of the fitting, you can actually see the delta T in our temperature difference here, where we typically like to see a difference of 20 to 30%. And our accessories, what this does is it shows that whenever you're running your conductor at 300 degrees C, starting at the mouth, we are running around 180 to 190 degrees Celsius. And as you continue into the accessory deeper and deeper, it continues to cool off. Reason for this is as you're running current through your conductor, trying to get to that specific temperature, the added mass of aluminum with the cross-sectional area acts as a heat sink. So with the combination of the aluminum strands on your conductor along with the cross-sectional area of your accessory, you're able to reduce that temperature with the same amount of current. The next product that we offer is our Quick Compress series. This was developed in the mid-1970s to try to help utilities reduce their installation times. Back in the mid-1970s, ACSR was still the name of the game. So with that, we intended to help utilities out in cutting down their installation times. With this, it's slightly different than our standard 2-die system, meaning it's a 1-die system. It uses our circular dies or CD type dies instead of the hexagonal shaped dies. With this, we also factory install the steel eye. As you can see in this image here, this is in the horizontal orientation. They can also be compressed in the vertical orientation when they're ordered. So we factory install the eye at our plant in Duncan, South Carolina. And then we actually pre-fill the aluminum body with that filler compound. So therefore, your linemen or linewomen do not have to inject any compound out in the field. With this, we use an aluminum style core grip that slides over your steel core, as you can kind of see the exploded view here in this picture. You will slide the aluminum core grip over. Our pre-filled aluminum body has a cap to keep that compound inside of it. Remove that cap and you can slide the conductor that's prepped into the body, and then you'll press with the CD dies from the start marks out to the mouth. It is a shorter compression length than your 2-stage accessories. It uses a slightly stronger grade aluminum than our 2-stage accessories. So you get a shorter compression length with the same holding strength rating of 95%. The only limitation with this is it's only rated for up to 100 degrees Celsius, max temperature, even for emergency or temporary loadings. Now, you might be asking yourself, why is that the case? We've done some internal studies to showcase basically once we get above 100 degrees Celsius, as we may be aware of different thermal expansion rates between aluminum and steel. Aluminum likes to expand slightly more than your steel would. So once we approach 100 degrees Celsius, that aluminum core grip will want to start to loosen off of the steel core. And then at that point, you could end up having the conductor slip out of the fitting if your tensions are too high on your line and you're operating at too high of a temperature. And then our latest and greatest, as we like to call it, is our Solo HD accessory line. Solo HD is a single die system and is designed for up to 250 degrees Celsius. It also has a shorter compression length than our 2-stage accessories. It's slightly longer than quick compress, but it is shorter than the 2-stage. Has to be slightly longer than quick compress just for the high temperature. Thermal rating gives the accessory a little bit more room to cool your line down in that heat sink area over the aluminum body. It uses one set of dies, and that's the conventional AH type. So with this, if you're using 2-stage accessories out there in the field now, you can still use the same type of tooling. We don't require any special tooling for this. You can use 60-ton or 100-ton presses with this, depending on the conductor size. We get to be able to use the single die system because of the specialized core grip assembly. So if we notice here, this down a little bit, you'll notice that we have a specialized core grip assembly where we have 3 aluminum lobes contained within a stainless steel sleeve. And then on the inside of that, we have an aluminum filler sleeve. How it works is once we start to compress over the body with our aluminum hex die, the body then presses into these 3 lobes over that aluminum insert sleeve over the steel core of your ACSR and ACSS conductors. So those press in, forming this hexagonal shape, and it joins the steel with the aluminum. And you can see the different cross-sectional views here where we have our aluminum body, our aluminum lobes and insert sleeve surrounding the steel strands of your core, and the stainless steel sleeve here. Some other key features is you can see the cross-sectional view of our dead end and then the splice down here. So like we mentioned earlier, the splice is going to be a mirror of our dead end in the same fashion as 2-stage accessories are. It's a one-piece core grip that's mirrored about where we cut the dead end off of the eye here. Compound is not required for these accessories. So if you'll notice, we end up compressing these accessories from the tongue side and we press all the way out. With our 2-stage accessories, where that compression barrel is over your steel eye, you do not press over the aluminum in that section. Reason for that being with the two-stage accessories, if you were to press over the steel eye section over the aluminum, it could end up double cold working the steel and can cause stress cracks on that steel and could jeopardize the holding strength over your core, which is going to be the majority of your mechanical strength. But for Solo HD, when we press over the body, like I said, these lobes press into the sleeve, press over the core. It's a one-piece system. There's no gaps or voids to be had. So the main function of the filler compound is to keep moisture out of the system. But with Solo HD, since it's going to be one solid piece and no voided area, there's nowhere for moisture to get into the system. So therefore, compound is not required. Conductor preparation is still going to remain. So the wire brushing or conductor cleaning of the conductor is still going to be required to get the oxidation layer off of your conductor, but it helps cut down installation time in about 50%. Like I said, it is faster installation than high temp. And the other key feature is the splices can be pulled through shiv wheels. So you'll notice here in our cross-sectional view here, you'll see a stop and do not press. On our splices, we have a specialized taper that helps reduce the stress on the ends of the splices to help protect the conductor from any additional stress when these splices are pulled through shivs. Just some more images here to kind of help out with the visualization of Solo HD. You can see a real life photo of a dead end eye here with all the technologies with the specialized core grip here. With this, there are no loose parts. There's a set screw that's actually contained in one of these lobes on the backside here that holds everything together. And like we mentioned, it's faster installation, uses standard type dies, and it's designed for 250 degrees C. Now, I know we talked about the operation temperature of our quick compress series being 100 degrees C max. And you may notice that we use a similar shaped core grip here with the Solo HD. But what we talked about with the expansion of aluminum on quick compress is not relevant with Solo HD, because as we start to expand, when we get to those elevated temperatures, since everything is self-contained within the stainless steel sleeve, that aluminum insert sleeve and the lobes cannot expand off of your core. So even at those elevated temperatures, this aluminum will not expand off of your steel core. And this is just the cross-sectional view. Once we installed, we cut it away. You can see the lobes around the insert sleeve and your stainless steel sleeve here once compressed. After doing some thermal testing, you'll notice we have our number of cycles. This was done in a comparison test for a current cycle test. You'll have our 2-die dead ends and our single die dead ends. The 1-die dead ends meaning Solo HD, and the 2-die dead ends being our standard 2-die high temp accessories. Our top line here is our control conductor running at around 250 degrees C. And then you'll notice down here, all of our lines are where our dead ends were. So all of them were running around 125 or below degrees Celsius. Just to kind of give a better visual comparison here, whenever we conducted our testing, we did testing on Grosbeak, Drake, and Falcon ACSS for qualifications. You can see the number of die bites it takes to press our 2-stage system versus our Solo HD, and this is a 2-scale length comparison. So with 2-stage, it took about 15 minutes to install for Drake ACSS, and for Solo HD, it took about 7 minutes for installation. Here in this table, you can also see the differences in length, number of die bites total, and then with Solo HD, as we mentioned, there's no compound required for installation. And then also similar applications with our splices. You can see sample installation time is 30 minutes compared to 16.5 minutes. It took 17 compressions compared to 27 compressions with Solo HD to our 2-stage here with Drake ACSS. The other factor that you got to take into account is that we're not having to change out the dies. So we make 13 compressions with the 16 SH die, and then we make another 14 with our 30 AH die. With Solo HD, it's just 17 compressions with a 30 AH die. And then just to kind of bring it all home and reiterate with Solo HD, high temperature can be used on ACSR and ACSS and the trapezoidal wire versions of both. So you could order one part number for a singular code name. So for Drake ACSR, ACSS, and the trapezoidal wire versions of both, it would be one dead end part number, one splice part number. It's a 2-component design with the specialized core grip and the body. No filler compound, faster installation. Splices can be pulled through shivs. The conventional dies, it doesn't take any special tooling. No new training necessarily. It might be a slightly different conductor prep with cutback links, but other than that, it's a lot easier to install. Since it's a shorter link, there's less risk for bird caging and a less banana effect as well. And then again, just a last minute comparison of all the different products that we manufacture. Here's your standard, your high temp 2-die, quick compress, and Solo HD. Thank you very much for your time. Appreciate it. If there's any questions, I'll turn it over to Randy to field them.
Great. Thanks very much. Good presentation. Thank you very much, Peyton.
Thank you.
Okay, first question up. Has the Solo HD been tested per the new ANSI C119.7? And if so, how has it performed?
So in our testing, we've conducted them when we developed this, it was 2017, 2018 when we started to develop it. We tested per the .4 spec, but we modified it for high temp. Since the .7 is still in a drafting phase or still in a draft phase, we have not fully tested per the new spec until it's been finalized.
Yeah, it's always useful to wait. Okay, let's see. Next one. I think you perhaps answered this, but they're asking, what specific advantages does the Solo HD single die system offer over traditional 2-stage compression in high temp applications, particularly in terms of long-term mechanical reliability and thermal performance?
So as we saw in the graph, you could see the
Yeah,
similarities between the 2-stage and Solo HD. Mechanically, we tested per the ANSI requirement. So 95% of RBS is still required for it. When we did our testing, I think we ended up reaching to close to 120% on Falcon, roughly around 110% RBS on some of the other sizes. So longevity, as long as there's no installation errors, just as you would see in 2-stage, there should be no issues with long-term performance. Actually, with Solo HD, since there's less steps to be taken, there's less chances for error as well.
okay. Next question, how do your connectors handle stress from wind or ice?
So with wind or ice, it would pretty much be typical of what your conductor would see. Actually, since it's one solid piece, we haven't seen any failures due to wind or ice loading. Typically, if you are installing any type of stock bridge dampers, depending on your wind loads, you wouldn't see any concerns from a compression accessory standpoint. And then with ice loading, again, it's not necessarily going to be harmful to the accessory. It would be more harmful to the conductor itself. But the compression fittings aren't going to add any extra risk with that.
What issues come up with quick compress at high temperatures?
Can you repeat that one more time?
What issues arise with quick compress at high temperatures?
So I think I mentioned it a little earlier.
Yeah,
Once we get to above 100 degrees Celsius,
right.
that'll core grip will want to loosen off of your steel core. So with that, you would end up seeing, or you could potentially see the conductor wanting to slip out of the accessories. Because that core grip is going to be your main mechanical holding feature of the accessory. But if you get to higher temperatures, you could worry about, depending on how high you get, you could worry about compound leaking out if you get to above a certain temperature. And then you could also start to see your conductor anneal as well, along with the accessory. So that's some other things. But once you get to above 100 C, the accessory or the core grip will start to loosen off. depending on how high you get, you could also damage your conductor before you damage the accessory.
What are the situations where it would be greater than 100 degrees C?
If there's any emergency loads that may require it, potentially operations need to end up pushing more current through a line just with the extra demand that we've started to see in the industry. Some don't realize that the limitation is 100 degrees C. So
Mm-hmm.
they end up needing to pump more current through their lines just to help meet the demand. And that would pretty much be where you would see it.
All right.
Or if there
Yeah.
was any type of, like I said, installation issue, the conductor wasn't fully prepped or wire brushed to remove that oxidation layer. That oxidation layer will act as an insulator and could heat the accessory up. If the line is, slightly older, it may not perform as great as a fresh new conductor off of a reel. That's some other cases where it could happen.
Okay. What is the next question? What's the design difference for the composite core versus the steel core compressions?
Good question. So for 3M and Southwire, we have an aluminum insert sleeve that goes on the inside of our steel eyes. That aluminum insert sleeve acts as a buffer between the steel and the composite core. We just know in compression that composite core may be a little bit more fragile. So that aluminum acts as a protective layer between the two. That's for 3M and Southwire. For CTC, they actually use a collet style housing to hold on to their core. So the CTC stuff would end up being a one die installation system, but the collet style assembly is a wedge type system that holds over the composite core. And then for TS, luckily with their aluminum encapsulation, there is no insert sleeve required on the TS accessories since that aluminum encapsulation already acts as that insert sleeve. Now, for composite core conductors, the other thing is we typically have to size up the body of the aluminum body. We have to size up the wall thickness to help with the extra current that they can hold compared to your traditional high temperature conductors. And then we also have to increase the size of the steel to help with the additional strength you get from the composite core accessories or from the composite core conductor.
Okay. Here's another question. It was mentioned that the high temp connectors are not for use on the latest advanced conductors MA5, ACCC, TS, etc. What solutions exist for the newest conductors?
So we have specialized accessories. So for the MA5 grade aluminum, we have a ultra high strength version of our accessories. So it's going to use a similar type of accessories, meaning a steel eye and an aluminum body. They're going to just be sized up for the MA5 to help with that extra strength in the steel. And then, as I mentioned just a second ago, with the composite core conductors, slightly larger steel, larger aluminum to help with strength and the extra ampacity.